to meet you.
Meet you too.
Give me a quick rundown of what's going on. What's the problem?
Yeah, we have an older van that we bought with the system already built.
Okay.
It's been, for the most part, I mean, we've had it for a few years, it's been fine, but recently, for some reason, like, when we're getting normal solar, the moon comes up like it's taken in too much or something, and then
Yes.
when, at the begin, like early in the day it's fine, then once like the sun gets too much, then all of a sudden it just stops taking in solar. So
Okay.
that's the main thing.
Okay.
And I guess as of like it didn't really do anything, and then today of course it did. Good timing. Something with, we have like a kill switch for the main system. Something between there and the system's loose because I was moving stuff and all of a sudden the whole system just turned off, and then I jiggled the wire and it turned back on.
I see.
Those two main things.
Okay, perfect. Let's go check it out.
Yeah.
Lead the
We're
way.
just parked like right up to the front end.
Okay. Based or
No.
how are you're just observing that it is or isn't charging from the actual charge controller itself, more or less?
Exactly.
Okay, and how many solar panels do you have up top?
4, right? Yeah, there's 4. They're just like kind of those flimsy ones.
Okay, so 4 100-watt panels.
I believe so. Yeah. I think some might be 110, but yeah, there's 2. There was 1 old one and 3 new ones.
Okay.
So I think I forget which is which, but they're either 1 or 110 each.
And then do you recall if they're wired in series or parallel or series parallel?
I think they there was a guy that we saw, and I think he changed it to series.
Okay. Okay, so main problems are you feel like the main problems that you feel like you're seeing is that the solar says that it's producing whenever the sun first comes up or the sun is starting to go down, but during the day, whenever there's plenty of solar, it's not charging.
Not taking in. Yeah.
Okay, and I will say that I am seeing that here, because when I take my multimeter and test between the positive and negative of the charge controller, I'm getting 0 volts. So that tells me that these are, it would normally tell me that they're not connected to the solar panels, meaning that there's a loose connection somewhere. But if you're actually seeing legit charging when the sun comes up and the sun goes down, that's kind of weird. Did it charge this morning?
I didn't really check. I mean, what I guess more so, it's like I notice when there's not a lot coming in. Like for example, like if we have like a workshop and I'll turn the lights on and all of a sudden it'll pick up from the lights and like it'll be bringing in a small amount, but it's almost like when there's too much coming in, it just like the moon signal comes up.
Gotcha.
So, I mean, I guess I just notice it more because obviously at the beginning of the day there's a subtle amount coming in, but once it gets to about, this time of the day or even earlier, it just goes straight to moon mode.
And then these two, the solar wires, are they going down probably through the wall immediately up to the roof?
Exactly.
As far as you can tell?
Okay. Yeah, and I kind of know roughly where they run, like behind a wall, because we updated some stuff and had to do the building off of. And one of those wires, and which I thought maybe was the source, is I think it's that one right there is loose.
Ah, yeah.
That's definitely part of it.
So that just came out.
Yeah.
So, I mean, I don't think this is necessarily your problem with the solar panels specifically.
Because that's just come loose before and it just turns the system off, or at least to the front tells me what's what. And I was like, oh, here it is, and then I got it semi-secured, and I'm like, oh, same problem. So
but the problem with that coming loose is if it's actually making power. If it's actually making power, whenever I get out of here, you can crawl up in here and see. But the outside of this terminal is sort of discolored, which tells me it's gotten hot. And so, whenever you have a loose connection, it creates a ton of resistance, and resistance creates heat. And so it could have just melted part of the terminal so that it's pretty much impossible to get that wire up in there and actually tighten down now to the degree that it's like damaged. But I've seen it before where, if this terminal, depending on how it's wired inside of the charge controller, it can start melting things on the actual control board inside. And since, the terminals for the positive and negative here are so close to what's going on here, then, you could definitely start to see how that could sort of damage that. What else we got? So yeah, I would definitely get in here and try to, get a screwdriver in and try to get that in there. Probably restrip that wire because it's kind of mangled at this point. We in all of our systems we do ferrules on those terminals, little sleeve of tin, and you crimp it, and then it just basically gives you a nice way to easily insert wires into terminals, so that that's sort of not really much of a problem. Now, as far as why we're not getting any voltage from the solar panels specifically, still not getting any voltage even with that loose. Yeah, I mean, I'm going to say that I'm going to highly suspect that there's probably a loose connection wherever these connect into the solar panels. So I would just take those MC4 connectors loose, make sure that nothing is melted up there, make sure everything's connected properly, because I suspect we probably can't get to them here, probably don't have a ladder, so on and so forth. But yeah, that's where I would check there. And then you'll be able to see, take a multimeter up there and test for voltage at the panels, because there's also a chance that, like, depending on how far up you don't have voltage, that can help you realize where the problem actually is. If it's a connection if you get up there and you take these wires loose from the solar panels, and then you connect, and then you check with your multimeter at that connection. If you have voltage, then great, it was probably that connection. But if you still don't have voltage, then you just have to keep going further and further until you get all the way to the panels to see where that voltage starts, and then that's sort of where you can start that troubleshooting.
Okay.
So yeah, priority one is going to be to get that restripped and get that put back in there, see if that is able to go back into that terminal, get that nice and secure. That's a priority one fix. Priority two is going to be check solar, and then I always like looking for other things. You were talking about the wiggling a wire and the system shutting down. Do you know which wire that was specifically?
Let me go do it, but I'm pretty sure it's either that black or red one that's coming from that top right corner.
Okay, and that's going to be positive going to, what's this going to?
It's one of those like kill switches for just turning off the whole system.
Okay.
For if, we need to shut down power and didn't want like a slow drain or whatever.
So this goes to a switch, and then it goes from the switch to that fuse block?
Mm-hmm.
Okay. So if you're jiggling wires and the system shuts down, it's a loose connection, like pretty much at all points in time. Especially considering that these are all 12-volt lights, and these 12-volt lights are powered from that fuse block. If you start wiggling that, your lights go off, then you just need to investigate that terminal, recrimp a lug, something along those lines. Okay, so you're wiggling that wire, and that was wiggling all of this, and you'll notice
I see right there.
that this connection is really loose. So I could have taken that off. So I'll get it finger tight, but yeah, get in here with a socket and tighten this up.
That makes sense.
So I'd say, if we've got a loose connection here and we've got a loose connection here, we're not getting any volts and kind of suspecting a loose connection, I think an overall system, retightening of everything is going to be probably a good idea, just to make sure everything is nice and tight. This terminal here, it doesn't have any heat shrink on it, and so I can just kind of move it around, and I can see that it's wiggling around inside of the terminal.
Yeah, it hasn't even been, nothing's been tightened for at least 2-3 years, so
yeah,
that makes sense. Especially in some things on the road all the time moving.
Yeah, for sure. And I'd say that's the biggest thing going on is they're just terminals and loose connections. none of these are necessarily loose. I'm not seeing a whole lot of like melted parts, which is good, because that's typically what we actually do see with melted components and stuff like that. I'm sorry, with loose wires. Mm-hmm. That's got a pretty severe angle on it. Let's see what else here. You know, right here, I'm seeing a little bit of like, Grace, maybe you can get in on that. So you can sort of see some pretty significant abrasions right there on that wire where it's been rubbing against the sharp fin of that inverter.
Yeah.
So I definitely get some loom around that. That's not a problem right now, but I'm also just trying to anticipate future problems. That would make a big spark. You know, the other kind of stuff I'm seeing here is, you know, from like a safety standpoint, you know, like I said, that's going to rub through eventually, and then that'll short out against that. And then since you don't have a fuse on this wire protecting any of this, that's going to overheat to the point where it's going to melt, and there's nothing to stop it. So every wire that comes off of this terminal needs a fuse. So this doesn't have a fuse. This one actually does have a fuse. So whatever that's going to your charge controller. This is the wire going to your battery, or to the switch that's killing power to your fuse block. That should have a fuse. And then is this going to alternator charging maybe?
Yeah. From the front, yeah.
Yeah. So yeah, that needs a fuse as well. You know, I would look into something like the Lynx distributor. It's 2 bus bars and 4 fuse holders that you could connect all of this to, and it would fuse everything properly. So that's one product, the Lynx distributor. The other one would be like the Blue Sea safety hub. It does the same thing in just a different form factor. And then that would get all your fusing proper.
Do you need a fuse for every battery if you have multiple?
Not like this, no.
Okay.
No, not when they're wired like this. So that's fine how it is. Yeah, just every wire coming off of the battery bank. Yeah. So since these wires are so short, it's not required for those to have fuses in this specific application. You know, I'll also say that, you know, this is a 3,000 watt inverter. Mm-hmm. And this wire is, it doesn't say how big it is on it, but just going by experience, this is probably like a 4 gauge wire. It's grossly undersized for that size of inverter. So a 3,000 watt inverter at 12 volts needs 4/0 wire, which is about as big around as my thumb. So, you know, this is only capable of handling somewhere in the 1 to 200 amp range. If you're running this at its full capacity, you know, it's going to pull 250 amps. So, you know, that would melt this wire, which melting wire is never good, especially when you've got wood in the close vicinity. So, yeah, I mean, just sort of bringing up a lot of stuff. So, like I said, points are fixing loose connections. So loose connection 1, loose connection 2, loose connection 3 is probably going to be on the roof. I just go ahead and replace this wiring from here to here whenever you do your Lynx distributor or Blue Sea safety hub to sort of get some fusing in place on this terminal. And, you know, just check out our YouTube channel and our shop for, you know, some examples of systems with proper fusing in them. That way you can kind of start to see, like, you know, which ones need to be fused and how that's actually accomplished. So loose connection 1, loose connection 2, abrasion here, but that'll be fixed whenever you swap out this wire and get proper fusing. And that's that. I would imagine that's all of that is probably sort of playing into, you know, your inconsistencies in how the performance of your electrical system is working. So yeah, sorry I'm not able to like fix the problems today, but I think that'll like get you going on the right track anyhow.
You're saving us hours of troubleshooting.
Yeah, certainly.
Appreciate it.
So that system, lots of loose connections. Like I said in one of the earlier system checks from yesterday, loose connections is, you know, it's going to very much affect the performance of a system and create hazards with melting wires. Loose connections, increased resistance, all that creates heat, and that's no bueno. Proper fusing is also going to be a great thing. We have system designs and diagrams and kits that include proper fusing, but if you're trying to design a system from scratch, YouTube search explorist.life where to put fuses, and we've got a video about that thing specifically. So those couple of things on that particular system is going to get it up and running without swapping out too many parts. The addition of a Lynx distributor or the Blue Sea safety hub is going to get it fused properly, with swapping out the wiring for the inverter, so that's actually properly sized wire for a big 3,000 watt inverter. This van we actually did some troubleshooting on last year at this same event, but still having some issues. The battery bank seems to be draining faster than it should be, and the solar doesn't seem to be keeping up. So we're going to go back to the back and see what we can find out. Wattage that your solar panels are putting out at any given time.
Okay.
Like your high score for the day, if you will.
Okay.
And so, 400 something, 423 watts, like that's actually pretty good. Especially for, when it's kind of hot outside, because solar panels put out less power when they get hot. And so I think that all is making sense. Now, your question about, how much power are these solar panels putting back into your system, and you've got that's 5 different days where they're putting out pretty much the same amount of power. And so you can look at the line next to yield, and it says 2.72 kilowatt hours, which is, let's see, so 2,720 watt hours, so it's equivalent there, divided by, let's call it 13.6 volts. So that's putting 200 amp hours of battery bank capacity back into your batteries every day. So you're doing watt hours divided by battery voltage equals amp hours back into the battery bank. That's sort of what that number means. So it's pretty consistent. You're not really having any days that's like way more than that. So we can sort of start assuming that that's probably what that array is sort of capable of. That's really consistent results, which is good. I think that tells us that your 500 watt array is operating properly. But then I'm going to look down here, and I'm seeing next to battery max, we've got 13.6, 13.6, 13.6, 13.6, 13.7, and so these are lithium batteries that probably need to be charged closer to like 14.4, 14.6. So that means that they're not getting charged to full, ever, basically. So even though they say they're full, the math doesn't really add up.
The only time they're full is when I drive, because it charges when I'm driving, and that always gets, so if I drive somewhere, when I get there, they're always at 99%. If I plug in overnight, like yesterday I was at 36%, last night I plugged in, woke up this morning, plugged it in, they were at 100, So if it sits and in my driveway for a week, it went from 99 Friday to 36 yesterday, just sitting in my driveway in a week. And that's why I'm like, okay, I know they're charging every day by the solar. I know solar's not enough, but it shouldn't still be draining 70, 60, 70%.
I'm just sort of seeing an inconsistency here with what your batteries are reporting versus what is being shown here in the history tab. Because in your settings, we have this charge controller set to charge to a max voltage of 14.4. And so if it was charging these batteries to full every day, then we would be seeing 14.4 on the max battery voltage right there, where we're only seeing 13.6.
Is it because it's not generating enough power? And when I say it's sitting in my driveway, like my refrigerator's plugged in. So that should be drawing. I'm trying to think what else is drawing from it while it's sitting there. Probably I'm sure there's things. My satellite, my Wii Boost.
None of that should matter.
My refrigerator,
that
but I feel like 900. I mean, it's still too much.
What's been your usage habits the last 4 to 5 days?
It's just I haven't.
Has it been sitting in the
It's
driveway?
been sitting in the driveway. I mean, I've been working on it, so I've been in it a little bit, but it's just been sitting in my driveway since Friday.
Okay.
My refrigerator's running. My satellite was running up until yesterday. But
Okay,
not
well, yeah.
using-
No, that's a good point because, I always sort of skip over the today because there's never
Right.
enough data. But yeah, 14.4, that does tell me that it's charging up to full, so why are the solar panels not charging to full?
And if
Oh, I see our problem. Okay, so
Yay.
so under battery preset, we've got this set to rotary switch. So there's a switch under here somewhere,
Oh.
and that's going to override everything that we programmed. So we just go into user defined, turn spurt mode on, 14.4, 13.8's fine, equalization voltage. We're going to turn that down a lot. Let's turn it down to 13.6. Oops. That's fine. Rebolt voltage offset, that's fine. Maximum absorption time. Chad, what's that? Is it 2 hours? Oh, you got a lot of batteries.
Yeah, 900.
2 hours. Equalization current percentage. Equalization is turned off, which is correct. Temperature compensation, we'll just turn that off. Low temperature cutoff, we'll leave that off. Okay, we back out again. Status. Okay, so now we're in bulk charging mode, and now we're charging at 340 watts as opposed to the 100 that we just were. So that one setting, the rotary switch that's on here that it was set to was overriding
What we set
everything that we set up previously.
Okay.
So
Yay.
I think you should see much better results from
Is
that.
it still odd that it's drawing that much power? Like, 'cause even if, like I said, I parked it at 100% on Friday, and it's just sitting in my driveway, that it goes down to 36% in 7 days with 900, even though that wasn't charging. I would think that even if I didn't have solar, that seems to be a lot to drain in 7 days.
It does seem like a lot, if you've got your inverter on the whole time, so that takes a little bit of power. Which that's kind of powering your TV even in standby when it's not necessarily on. Your Starlink is on, probably.
I turned my water heater off because I found that was huge.
Water heaters.
So when I turned that off,
demand.
it helped a lot because it went
Yeah.
down to. I went on a trip, so we got there, parked the van, came back, and it was 7%. The inverter had turned off, and I was like, "What on earth?" It just sat here, but the water heater was on, and so
Yes.
now I know if I turn that off, doesn't drain as fast.
Yes.
But what else? Is there something else that I'm not?
You know-
I have unplugged the stove, the oven, the coffee, the frother. I had all that unplugged, just knowing because when it sits there, it's still drawing something.
So go back into your battery monitoring app. So what this is telling me is this is gaining a little bit of power. So you if you go into here, I'm not really familiar with these batteries or this app necessarily, but I would be looking at this little gauge here, and then you can sort of see what is using power versus what isn't using power. And I'm sure if we turned solar off, we would start to see losing power because something is using the power. Mm-hmm. And then you can sort of go around and start
Click
turning
one thing
things
off at a
on,
time.
turn it off, and you can sort of start to see how much power different things are using at any given time.
So what would this look like? Tell me what I'd be looking for if I turn something on or off.
Let's do you have a switch for your solar? Is that an option?
I
like
don't.
a battery isolator, or I'm sorry, a solar isolator?
I don't. That's a great question.
Go back
I don't
into your
It's been a while.
Victron Connect app. So to sort of troubleshoot this, we'll just go here. Charger enabled. I'm going to turn it off. Okay, charger disabled. And then go back to your battery menu again. So now you can see that we're losing
-3,
we're
okay.
losing 3 amps. So I've turned, you're not connected to shore, you're not driving.
Something's drawing
Solar
3
is
point.
off, and so
Okay.
you're drawing 3 amps. And you know what 3 amps is in relation to your battery bank. If you have a 3 amp draw for 10 hours, that's 30 amp hours.
Okay.
So 30 amp hours, for every 10 hours of draw. If that's sort of your like resting draw, you said it would drain in like 5 days.
In 7 days, it went to 7% when I had the water heater on. 100 to 7.
So a 900 amp hour battery bank divided by 3 amps. I mean, that's 300 hours, but that's divided by 24. That's 12.5 days. So your batteries would go, if that's all it was drawing, which if you had the water heater on it, it'd be drawing way more than that, like 100 plus amps.
So it should be able to go, with what it's sitting at today, it should be able to go 12 days.
Yeah, but now that we fixed
now-
your, because your solar wasn't really working very well.
Right.
So with the solar now working properly, I'd imagine it's going to be fixed, because as soon as we turned your solar on, you went from -3 to +3, and it's only 10 o'clock in the morning. And it's kind of hazy, cloudy today.
So with a +3 during sunlight, and
Uh-huh.
then maybe this -3 during
Overnight.
overnight, that
Yep.
should keep me about steady state maybe.
Yep.
Ish.
Yeah, it should be charging every single day if your water heater's not on and it's just sitting here. Okay,
Thank you. Super helpful.
of course. Yeah. So a settings issue.
Yeah. Well, good. I hope it
Yeah.
was helpful for you guys.
Yes, of course. Yeah, it's always like fun to see. Well, because like that's typically not an issue, the rotary switch, because that's not the default setting, and so it's easy to glaze over things that aren't normal. So
Yeah.
that must
And
have
who
just
knows
got
how we got that
clicked at some
there.
point in time. So with the settings set to user defined instead of rotary, the rotary is that switch underneath, and we don't want that to be taking control. We want the user defined settings in the settings menu of the charge controller to function. So we set it to that, which made solar work way better. And then we also got into the battery app to sort of find out how much power is being drawn at idle when it's just sitting there, so we could better understand how fast that massive battery bank is actually going to drain. Sort of armed with those two things, I think she's kind of set up for success now. So in this particular system, we're going to be troubleshooting a solar charge controller that isn't working, you feel like it should, as well as a DC to DC charger also doing the same thing. You mentioned that you kind of had it off and on depending on if you're driving or not, so there's a setting that will change. We'll fix that. So we'll get the Victron Connect app up and running, and then we'll dive into it. Okay, cool. So we're going to be troubleshooting why we're seeing only 11.3 volts on the input, and well, the output is no volts because it's not putting out any voltage. The engine's off, so we're going to be checking the voltages at the terminals and trying to figure out why that is the case. So I'll hand that off to you. So the input is the one closest to us. Output, furthest one. So I will say that, I don't know that this is what's necessarily causing the problem.
Yeah.
But I just took a picture of the terminals, and you can see that one's kind of out a little bit.
It is.
And it's also dripping adhesive out of the heat shrink terminal.
Ooh.
And so I imagine
so it did get overheated.
I imagine that got a little hot, and
Okay.
so that would probably be something worth getting in, recrimping, putting back in there, and making sure it's nice and tight.
Yeah, okay.
Now this is on the output side, so that doesn't explain
Yeah.
why we're only seeing 11 point whatever volts. So
I never thought about getting there with a picture.
tricks in the trade.
Pull this out.
So I'm getting 12.45 volts on the input. Go ahead and turn your van on.
Yep.
So do you ever see this turning on when it's in this mode?
This is just very, very recent, within the last week. This is all within the last, give or take, week.
So what I'm noticing here, so the van is running at the moment,
Yep.
and this app is showing 11.3 volts on
Yep.
the input voltage.
Yep.
But whenever I actually take a reading, we're 14.4 volts.
Okay.
So, we're getting an actual reading of 14.4 volts, from
Yeah.
from the multimeter,
Okay.
and the input voltage from the Orion on the app is saying 11.3. And so that's kind of a weird deal, because this should say what is shown there, and so that sort of tells me that there's something going wrong with the unit itself.
Is it okay?
And to sort of double check that, I pull the remote connection pin out of the bottom of the Orion, and that should relay here under why is this device off. It should say the remote port or the remote pin has been removed. So that's why it's off. But it's not saying that. So that sort of tells me that there's something wrong with the unit itself, and you should probably look into getting it replaced, which was this purchased from us?
No, that was through. I bought the whole everything electronic. If I remember, was bought through Battleborn.
Through Battleborn. So just let them know that whenever you contact them for warranty replacement, just let them know that the actual input voltage at the battery input terminals is 14.4, and it's registering as whatever that was,
Right.
11 point something or another.
I got lots and lots of screen prints of that.
On the app, and that it's not, it's basically just not letting it communicate.
Okay.
And so I would, take that off. It's going to be kind of hit or miss depending on if that terminal is damaged, because if that terminal got hot and overheated and melted something inside, they may work with you from a warranty standpoint.
Okay,
But
yeah. What is a warranty on a Victron stuff?
5 years.
It is, okay.
So we can tell that the charger is off because it says state off, and then we can get some more information because below that it says why is the charger off. So you can click on that, and then it says insufficient PV power. And so that's just telling you the charger's off because there's no or not enough PV power. This is expected during nighttime and doesn't indicate any problem. And it's not nighttime. Kind of cloudy, but ultimately we should have power coming in still. So we're getting 0 volts coming from your panels. So 0 volts from the panels tells me that there's something likely entirely disconnected. Do you have like a solar isolator or a switch that you can turn off and on? It's a fairly classic loose connector situation. Is I would start at the PV ports of your charge controller, which is back in there, I suspect. And so I would just start taking voltage readings at every connection point all the way up until you find voltage. So you'll have your connection for positive and negative at the charge controller. You're not going to have voltage there, but go ahead and check just to make sure. And then go to your solar isolator and see if you've got it on one side.
Shut off and turn on.
Yeah. See if you've got it on one side, see if you've got voltage on the other side.
So like in your testers, you're saying that you can actually just put this around that and you can get that?
So
Or you still have to use...
You still have to use the probes.
You do have to use... you do have to
positive and
use the
negative.
probes.
This is for just
120.
like this is for amps.
Nope.
You wouldn't have to undo the connectors. You just have to take the cover off. And then you've got the screws that you use to tighten the wires into there. You can just probe those screws with your multimeter, and it'll tell you your voltage there. So, probe the screws on the charge controller, probe the screws on both the incoming and outgoing side of that breaker, and then I suspect you're probably not going to have, unless something's wiggled loose from the charge controller, I don't suspect you're going to have voltage at any of that. And then from there, you're going to have to go up to the roof and see. So that one faulty product, most likely the Orion. Whatever you read with a multimeter is kind of foolproof for the most part. And what you see on that multimeter, you should be seeing on the Victron Connect app. And if they're not quite meshing, something's wrong, either with the multimeter or with the device. The solar panels, that's another pretty classic case. And he had 0 volts coming in from the solar panels, which means something is loose or something is just actually totally not connected. And he hadn't put eyes on his charge controller in a couple years, and so there's a good chance that something may have wiggled free. especially since we saw that the DC to DC charger had a wire that had wiggled free, overheated a little bit, and worked its way loose. So I think getting eyes on all of your connection points and making sure your system is installed so that you can get to all that stuff regularly is a great idea. Personally, try to, annually or every time I change my oil, check those connection points to make sure everything's nice and tight and we're not having any issues.